All right, section 6.3, second day of notes. So for this one, we are focusing on the same polynomials that we were talking about, but we're talking about end behavior. So end behavior of a function is what happens to the value of the function as the dependent, aka x values, gets very large or positive, or very small is negative. Okay, so in other words, what is happening at the end of the graph, hence end behavior. So you're really focusing on the arrows, okay? So this is a notation that you're going to have to get used to, and hopefully we seem pretty familiar with it by the end of this lesson. So all it's saying is as x is going towards positive infinity, f of x, which this is referring to y, goes where? Okay, so you're going to fill in infinity or negative infinity. That's pretty much the main ones that you'll see now. You'll see other stuff later though. Okay, so for example, if you look at the right, okay, there's the graph. It's a quadratic. If you go to the right side of the graph, explain what's happening to the graph. As we go to the right towards positive infinity, the graph is going up, which is positive infinity. As we go to the left, so this way, negative infinity for x, the graph is still going up. So that is also going towards infinity. So you're just focused on whether it's going up or down. Okay, the end behavior of a polynomial function depends on two things. Okay, big thing is it depends on the degree and it depends on the sign of its leading coefficient. So case one, all right, we are talking about an even degree, so hence our squared to the fourth to the sixth, okay? So if it is even and positive leading coefficient, notice how it's a positive 1, positive 1, positive 1, right? All of your graphs will always end like this, okay? They are all pointing in the upward direction. So no matter what, whether you're going to positive or negative infinity, your graph itself, the y values, will always be going to positive infinity. So it is going up, it is going up. In the second case, you have an even degree, but a negative leading coefficient. Notice how it's negative 1, negative 1/2, negative 1, right? Then they're all going to be pointing down, right? And if they are going down, we are going towards negative infinity. Obviously, if we did even, now we're going to talk odd, okay? So if it's an odd degree, so 1, 3, or 5, basically, with a positive leading coefficient, as you go to the right, it's going up, and as you go to the left, it's going down. Okay, so notice down, up, down, up, down, up. Okay, no matter what, that's what it's going to be if it's even and positive, or sorry, odd and positive. So as we go towards the right, or positive infinity, it is also positive. And as we go to the left, which is negative infinity, it is also going negative because it's going down. So they match. So if you have an odd degree and it is a negative leading coefficient, like negative 2, negative 1, negative 2, right? Notice how it just flipped it. So now it's up, down, up, down, up, down, the whole way. So as we are going to the right, it is decreasing. So it is going down. And as we go to the left, it is increasing, going up. So down means negative infinity, up means positive infinity. So if we look at these right here versus these here, it's the same thing, but it's flipped. So if it's odd and positive, it matches. If it's odd and negative, it's the opposite. And what I mean by that is negative infinity, negative infinity. Whereas down here, negative, positive. Okay, now these are cases that you can memorize, and you probably should. You could always graph them on your graphing calculator, but I don't know if you'll have enough time to do that all the time throughout your time. Okay? So again, sometimes I draw it off to the side. So we are talking about squared, so a quadratic with a positive, right? So if it's quadratic and positive, it's going to be like a U. So based off of that, we know that both of them are pointing up. So it doesn't even matter which one is over here. You know both of them are going to end up towards infinity. When you look at number 2, and again, we can just focus on these if you wanted to, if you're not sure what the graph would look like. Negative and odd would look like this. Or you just remember, negative and odd means that it is opposite of what it says. So if this is positive, this one's negative. This is negative, it's positive. Okay. Now, again, you can focus on the graph. So on the right side, it's down, so that's negative. On the left side, it's up, so that's positive. On the next one, we have negative and then an even. So I know it's going to be something like that, where it has like a little dip, but I just know it's going to be like a U. Again, they're both pointing down, so that doesn't matter. They're just both going to be negative. And then we have a positive odd. So it's very similar to the one above. It's going to be something like that. And remember, when it's positive and odd, these match. So positive, positive, negative, negative. Okay, so for each graph, we are going to describe the end behavior and then determine whether it represents an even or an odd degree. And then we're going to state the number of real zeros. Remember, real zeros are where it crosses the x-axis, okay? And that's always going to be at most the degree. It could be less, but it can't be more. So if we look here, first one says towards positive infinity, so to the right. It is going down, so that's negative infinity. As x goes to the left, our graph is going up, which is a positive infinity. Based off of this graph, because our end behavior is not the same, that means this is going to be an odd graph. The only time that it's even is if they are the same direction. Our number of zeros, 1, 2, 3. So that does mean that our highest degree is going to be x to the third. Or our lowest degree, I should say. Okay, so number 6. If I look, both of them are pointing down. Anytime they're going in the same direction, that means that it's an even one. And both of them going down means I don't even really have to think about it. They're just both towards negative infinity. We notice it crosses the graph at 2 spots. So there's at least 2. On the next one, because one is down and one is up, that means that it has to be an odd. And it only crosses the x-axis at one point. So it only has 1 0. I should say 1 real 0. Obviously, this isn't just a straight line, so this would be like an x to the third or x to the fifth still. It just has 1 real 0. So as we go to the right, it's going up, positive infinity. As we go to the left, going down, negative infinity. And then we have our last one. Okay, again, I'm going to start with even or odd. This is an odd function because one's pointing up and one's pointing down. The number of zeros, it crosses the x-axis 3 times, right? 1, 2, and then 3. And as we go to the right, this is going up, so that's positive infinity. As we go to the left, we're pointing down, which is negative infinity.